Hello guys, welcome to today's class. So today we're looking at elasticity. Elasticity. So elasticity is the property of a material that it is the property of a material that enables it to return to its original shape and size after the external force causing deformation is being what? Removed. The external force causing deformation is being removed. The ability of the material to return to its original shape. For example, this band, this is a material. The ability of this material to return to its original shape. After stretching this material, either the material is being compressed or stretched. After stretching this material, the ability of this material to return to its original shape after the force, external force. Okay, my external force, I'm applying a force on this material now. So the ability of this material now, after the external force is being removed, for this material to return to the original shape is called what? Elasticity. And elasticity can also be defined as the ability of an object or a material to resume its normal shape after being stretched or compressed. So in the study of elasticity, there are some keywords you are supposed to understand. So we have elastic what? Deformation. And elastic deformation occurs. The first one is elastic deformation. And elastic deformation occurs when a material is subjected to a force. When a material is subjected to a force, causing it to change shape temporarily. For example, this is the original shape of this material. So if I apply a force to this material and I cause it to change shape by adding extra shape, like extra length. So the ability of this material that is subjected to this force, causing it to change this shape temporarily, is called what? Elastic what? Deformation. And the change of elastic deformation is what? A temporal change. It is a temporal change because after this force, you remove this force. After I removed the force that I'm applying, it will return to its original shape. So another word is a plastic what? Deformation. Plastic deformation. A plastic deformation occurs when a material is still subjected to force beyond its elastic limit. When the material is subjected to a force beyond its elastic limit. For example, I can apply force to this material beyond its elastic limit. Comes what? Plastic what? Deformation. Beyond its elastic limit. When a material is subjected to a force beyond its elastic limit, in the case the material undergoes permanent what? Change. Permanent change. For example, the material can either break. It can either break. It undergoes what? Permanent what? Change in shape and what? Also in size. Even after the force is being removed, the material undergoes a permanent what? Change. That is called what? A plastic what? Deformation. So remember, plastic deformation is what? Is permanent. The change in elastic deformation is a temporal change. The change in elastic deformation is a temporal change. While the change in plastic deformation is permanent change. The change is permanent. So another keyword is called stiffness. Stiffness. And stiffness is the ability of a material to resist deformation. The ability of a material to resist what? Deformation. Resist being stretched, resist being compressed, resist different. When a different material with individual stiffness interacts in parallel, and the net stiffness is defined as what? When the material interacts in parallel, the net stiffness is defined as stiffness defined in parallel. When they interact in parallel, the net stiffness is equal to so also in series, when different material with individual stiffness interact in series, the net stiffness is defined as 1 over k net equal to so when we start solving some problems on stiffness, elasticity, you understand better. So the SI unit for stiffness is force per unit length. The SI unit for stiffness is force per unit length. Force per unit length. Force divided by length, which is what? Meter. Newton per meter. Newton per meter. This is the SI unit for what? Stiffness. So now the Newton per meter length depends on a linear deformation. When a linear deformation occurs, so that is when we have this SI unit, Newton per meter. So but when a rotational deformation occurs, we have Newton per unit what? Rad. When a rotational deformation occurs, we tend to have what? Newton per unit rad, which is Newton per unit rad. So also, Hooke's law. Hooke's law is another another parameter you are supposed to understand, or another keyword you are supposed to understand in elasticity. Hooke's law plays a major role in elasticity. So we have Hooke's law. And Hooke's law states that an applied force is directly proportional to the extension. States that the applied force on a material is directly proportional to the change in length. Is directly proportional to the what? To the deformation. Can also call it extension, deformation, the change in length. The applied force in any material is directly proportional to what? The change in length. So introducing the stiffness K, we have the force is equal to what? The stiffness times what? The change in what? Length. The change in length. So now this relationship is best described by Hooke's law. This relationship is best described by Hooke's law, which states that an applied force is directly proportional to the extension it produces, provided that the elastic limit of a material undergoes consideration is not exceeded. So Hooke's law states that an applied force is directly proportional to the extension. It says